to Enots Engineering. I'm Alan. This week we'll continue fitting the scales and the digital readouts to the lathe bed, and we'll also fit this one 150mm to the cross slide. And I want to fit it to the cross slide without drilling any holes in the cross slide. We'll then look at the digital readout monitor and see how we can set it and whether the readings we get are true. So let's go into the workshop and see how we do it. Now, while I had the saddle off, I drilled 2 holes in the back of the saddle to fit 2 cap heads and made this piece of 2-inch angle aluminium to fit the end of the saddle. Just finished fitting that one axis. I've had to re-space this out here, change the spacer for a bigger spacer, because the screws on the sensor down here hit the casting along the bottom. So I've had to pull this rail out and then move everything out. I've made this is a standard piece that comes with it, this angle piece. I've just cut it in half. It did look like this. I've cut it across the top of those 2 holes so that that piece is down there. Then I've made another piece of aluminium to bridge the gap between this part here, between the angle aluminium and the bracket, and then that contains spacers to build up the difference so that the sensor is running in the centre of the track without rubbing the rails. I've left a 1/15 thou gap between the bottom of the rail and the sensor, so when I move it, it doesn't rub on the aluminium. So that's the first one fitted. I can put the aluminium cover on, and I've drilled and tapped some holes for 2 screws, and there's the cover fitted. One of the biggest problems of fitting digital readouts to this cross slide, on the Boxford you have your adjusting screws there all the way along for the jib strip. You've also got this casting shape here, so it's not a flat face. If you decided to put, say, a hole in here to fix the scale to, then you'd have to put a hole in the end somewhere here to pack it out. Let me show you. This is a 6-inch digital scale. You're going to put it across like that. Normally they go upside down, so if you tried to put it upside down, you'd have to get the scale in the middle. First big problem you'll have is the height of this readout is above the surface of the top slide. That means that when you've got your tool post and your compound slide in here, you won't be able to pivot them round because they'll hit this. You can't fix your digital readout that way. You have to go sideways. Now if you go sideways on this, you have the height, so you can bring it up to the height, but then the problem you have is this gap here and the step. You could put the scale there because you only need to drill 1 hole at each end, but then the problem you have to put the reading head somewhere in the middle or at the one end, which is difficult. Also, you start to interfere with your saddle clamp. This is the front view, and the problem you'll have is this area here. If you look at the casting, if you're going to screw your digital readout into the side of this, you can see there you've got a jib strip. The casting thickness there is about 1/2 inch. So your digital readout screw would have to be lower than these, because you still need to get at this, which puts it dead in line with the jib strip. So it makes it virtually impossible to fit the standard glass scale. I've set up the vice. This is a clocking on the back of the vice jaw, so that's parallel in that direction, and I've also checked that the vice is square in this direction. I'll just put another 1/15 thou cut on. I'm using my dial indicator on the carriage to give me the depth of feed, but at the moment the traverse is working. Here's the finished T-nut, I suppose you call it. Slides in here. I just need 2 holes to be drilled and tapped so I can clamp it. Then I can carry on with the rest of the project. I've just put my vice back on the drilling machine, and here's a little tip. On the bottom of the vice I've bolted a straight edge, just a piece of aluminium. So once you've squared the vice up, you bolt this in position, and then next time you put the vice on, you just move it up to the edge of the slide and you know it's square. Now that can lock on there with those 5mm cap heads. This is the pin that's on the end of the T-nut, and I've just used a centre punch to pin it over in 3 places to grip this angle iron so I can set it in the correct position. I've just slid that into the cross slide, and now I'm checking that this angle iron is level with the top face of the cross slide before I get this welded in position. So this is the part I've made, a T-nut with 2 cap heads to clamp it into the slot, a hole that's drilled and tapped on each end, and this just slides into the cross slide. This is shaped to the cutout in the top slide. Then the digital scale will fit on here. Then all I need to do is fix the reader to the aluminium plate I've already fitted, and to do that I've got this piece that I've shaped. That fits under there with 2 screws, and then the digital readout will be bolted to this, and that's the only way I could figure out how to fit a digital readout to the cross slide. This is the standard plate you get with the scale. I've just cut it down so it'll fit on this. These 2 slots on each side hold the readout. The only downside of this is when the scale's fitted, I can only get at the 4 screws for the jib strip. I've set the dial indicator to 0, just touch it so you see it moves at the end of the scale. Now just wind this along. Each division on the clock is a thou, and the travel that I'm doing is 6 inches. Now that's moved 6 inches and it's showing less than half a thou. You have got adjustment on the holes. You can move the screws in and out. If you look at the hole on the end, this one is elongated, they're all like that, and the way I fix this is through a hole in the end that way. You can see I can still use the clamp, that's not interfering with the clamp. That's the cross slide scale fitted. I'll have to think of a way of putting a cover over that. And as I wind it across, this part stays still, this part moves. You can see here it's below the surface. The tool post will still fit on there and swivel round without any of this interfering. Well, this will wind right down until this end hits the stop. I can still use my clamp. Well, I've nearly finished fitting the scales. I've drilled some holes through the metal plate and put some cable ties in to hold the cables in this position, and then use cable ties to hold the two cables together. And then along the wall at the top I fitted this plastic trunking where the cables go in, and they come down the other end by the readout. This is the bracket that you get with it. Comes on, you can screw it to the wall or onto your machine. It's got 2 big holes each side for wood screws and 4 tapped holes so you can screw it to the side of a machine. You can swivel it backwards and forwards. It will also swivel round and tilt up and down. You also get the cable ties that I've used just to temporarily hold the cables in position while I finish off fitting. All I need to do now is make a cover to go over here to stop swarf getting into the reading head and going into the scale. So what I've done is come up with this little piece of sheet. It's made out of a car registration number plate, and that just slides into there, in the gap under there, slides along, pushes into position. I'll show you what it looks like. There's a piece bent over at the end to cover this area. This cut out so you can still get into there if you need to. This piece bent up at about 45 to stop any swarf going down this area which is exposed. This piece on the end bent at 90 degrees just to rest up against the reader holder, and that just drops under the angle iron. You slide it along and it just holds that into position. So looking from the side, any swarf that comes down onto here will stay in this part. Here it'll still drop onto the edge, which I can wipe off. Anything that comes onto this part here where the reading head is, this little lip should stop it getting down the gap. Now if you want to change the settings in the display, when you switch the power on, just hold the enter key or the S button here. Enter key is a bit bigger so it's easier to do, and it will go into setup, and then it will say select type. Now you can scroll through the different settings that you can change, and set the different settings to whatever you like. In the book that comes with it, it tells you what each setting is. These are the settings. Got a few different settings in there. And the only thing I've changed is the axis, the amount it displays. Because I've only got two axes, I've decided to use the X axis as the cross slide and the y-axis as the movement along the bed. I wanted to change the reading of the x-axis so it would give me diameter, which is double the reading. So when I move it in 1 millimeter on the cross slide, it shows 2 millimeter off the diameter. So the two things I changed were the diameter display mode and setting the y-axis, which is the bed of the lathe, so that's towards the chuck and away from the chuck. I changed it from negative going towards the chuck to positive, and the reason I did that was so that if I face the end of a bar off and I want to move 10 mil along the bar, it'd give me a positive reading rather than a negative reading. And the reason why I changed it to diameter on the x-axis, which is the cross slide, was so if I took half a mil off, it would reduce the diameter by a mil. So I can set up the diameter on the x-axis and I can see exactly what the diameter is as I'm machining. That's the theory. So this is how you do it. You hold the enter button and switch the power on and it goes into this menu. Then you scroll up and down with the arrow buttons until you get to, there's direction. You press enter and you can see here on the x-axis I've got in direction 1. This just changed the positive and negative, and in the y-axis I've left it as it was set. These are set to 0, 0, so you can change the direction of either axis, and it's the same on the 3-axis one. You can change the direction. So once you've selected the direction, press enter, and then you can move on to the next one, which is RD mode. So I'm looking for RD mode, type RD mode. RD mode is radius or diameter, and then all you do is enter that, and you can see in X I've selected 1, so you put a 1 in X, which says I'm using the diameter, and in Y it's 0 because it's reading exactly as the scale sees. You just press enter and then scroll down. I'll go through all the different settings until it comes to quit. Press enter, and there is a setting. I'm setting my cross slide to 0, so I'll set it to 0 on there. Now I'll turn the cross slide half a millimeter roughly, and you can see on here it's double, so that gives me an idea of the diameter of the work. I'll turn the diameter, use a micrometer or digital caliper to give you the size, set the size in there, and then from there on you know exactly where the tool is to give you the diameter that you're looking for. On the y-axis, as I move along the bed, just gives me the normal reading, the exact reading of how far it's moved. Finished fitting the scales, and now it's time to see how accurate they are. I've put my long range dial indicator, each small division's a thou, and I've clocked up the front of my tool post so that it's parallel with the dial indicator. And now what I'll do is set my X and Y to 0, go back to the dial indicator, and I'll move in. It's 100 thou per revolution, so I'll go in 5. So on the readout it says it's 0.5 at 0059, nearly 6/10 up. So I'll go in another 5. Now on the readout it says 1 inch and 4/10 up. So I'll go in another 5. And it says 1.5 inch and nearly 1 thou up. Now the problem I've got is that the digital readout scale, or is it the dial indicator? But there again, a thou in 1.5 inches. So what I need to do is get another dial indicator and see if I can reproduce the same error with a different dial indicator. Now I fitted another dial indicator in the chuck, just gripped it very lightly, set that to 0 and set my scale to 0. So now I'll move in, this is 10 thou, that's 100 on the dial indicator. If I look over to the readout, on the readout it says 100 exactly. I don't know how far I can go on this one, move it in again. That looks like 0. So I think that proves that the scale is reading right. Oh well, that's it for today. I hope that was useful, and we'll see you next time on Enots Engineering.